So relations and functions today is what we're going to go with. Today is Thursday, so this starts Unit 2 today. Okay? So here we go with it. Okay? So first off, we have to talk about what an actual relation is. So these would be notes that can go into your notebook and for future reference and things of that nature. Okay? So a relation is a mapping or pairing of an input with an output. Okay? So a relation is a mapping or a pairing of a relation with an input or pairs an input to an output. Okay? Meaning you've dealt with them already. Okay? Last unit, we were dealing with relations. When we were simplifying expressions, when we had something along the lines of 3xy plus 7x squared y, when x equals 2 and y equals -3. We'll say that. Okay? Not yet, Dietz. I haven't given it yet. Okay? So that's a relation. Okay? And so because the inputs in this case would be 2 and -3, and the output would be whatever we get if we plugged in 2 and -3 into that. Okay? That's a relation. Okay? In a relation or in a function, we have two key, whoa, the tap breaks, that went a little too far. We have two key parts. The first part is something called the domain. The domain is the set of all input values. Okay? So it's what you put into the relation to get out the outputs. Okay? The range is the set of the output values, the outcomes. Okay? So domain is in, range is out. Okay? So domain is all of the things we put into a function. Range is what we get out of the function. Okay? With both of those, I ask that you use set notation. And set notation is these fancy squiggles going on here. Okay? Now, truth be told, I have a very small artistic bone in my body. Okay? And so I can't draw these squiggle or these set notations very good. So how I get around it and how I will allow you to get around it, because I would never have you try and do something that I can't do, is I will also accept squiggles as set notation. Okay? The nice thing about taking online tests and things of that nature is I'll be able to type in the proper set notation. But for on a homework or on a week worksheet or something along those lines, I would also accept squiggles as your set notation. Okay? There are 4 different ways that we can represent a relation. Okay? So the first way that we can represent a relation is we can list ordered pairs. Okay? That's one way to represent a relation. Okay? You can just give me a list of all of the different points that would make that relation true. That's one way. For all four of these different ways to represent a relation, I'm going to use those four distinct points. Okay? So the second way that we can represent the same relation is I could make a table of values, the old X, Y, T chart, if you will. That's another way that I can represent the exact same thing. So in this particular T chart, the point 4, 2 is represented by a 4 being in the X column and a 2 being in the Y column. Likewise, 3, -1 is right there. -1, 5 is right there. And 4, -1 is right there. Okay? The third way is, now don't freak out when I do this way, okay? The third way is by graphing. Okay? We can graph the relation on a Cartesian coordinate system, X, Y graph. Okay? Color code them again, Linz. So 4, 2 is this one. 3, -1 was blue. That's this one. -1, 5 was green. That's this one. And 4, -1 was purple. That's that. So we can just straight up graph those points. These three methods you have all seen before. Okay? I know it. You don't have to tell me that you've seen these before, because I know you've seen them before, because I know you had to get through Algebra 1, Algebra 2, and Geometry in order to get to this point. Okay? The fourth one, the last one, is probably the one that you haven't seen yet, and that is called a mapping. So in a mapping, what you do is you take all of the domain and you put it on the left. And then for every number that you have in the domain, you draw an arrow to its corresponding output in the range. Okay? So let's color code these arrows. So 4, 2, that is this one right here. 3, -1, that is this one right here. -1, 5 is this one right there. And 4, -1 is this last one there. Okay. So you just take the X term, or the X parts, and you draw lines to their corresponding Y parts. Okay? Questions, comments, concerns, clarifications? All good? Okay. Let's try one here now. Okay. So I want you to do three things in this problem. The first thing is I want you to tell me what the domain is. The second thing is I want you to tell me what the range is. The third thing is I want us to draw a mapping of this situation. Okay? All right? So let's knock these out. So the domain, D. Okay? We can, capital D, we can short that up. That always means domain in math. Capital R always means range. Okay? We need some set notation. So we can try and draw this funky thing, but see there, it kind of looks like Alfred Hitchcock's face, and so you guys probably don't even know who Alfred Hitchcock is. So we can just draw our funky squiggle for set notation. Domain from earlier in our notes says it was the set of all input values, or it's all the x's. So this is a domain. That's part of the domain. That's part of the domain, and that's part of the domain. For ease, for clarity, to make it easier on everybody, we'd want to put those in numerical order. -3, then 2, then 5, then 8. Love it. Okay? So that is our domain. If there is a repeated value in it, okay, we don't write it twice. Okay? We don't write anything repeated. Okay? Then we're going to go and do our range. Now our range is going to be all of the y values. Okay? If you'll notice when you're doing that first inspection, there is a repeat of the y values of 7. So I don't need to write that twice. I can just write that once. So my range would be -1, 4, and 7. Now it comes to the mapping portion of it. I'm going to move this over to this side. Oh, too far. Now the mapping portion is, so now that I've figured out my domain and my range, I'm going to go -3, 2, 5, and 8. If you want to put it in a circle, that's fine. If you want to put it in a rectangle, that's fine. If you want to just leave it without anything, that's fine too. Okay? And then -1, 4, and 7 is my range. And so now I just need to connect the dots, or connect the arrow, so 2 goes to -1. So shabam, there's 1. We should probably make that a little bigger. And 5 goes to 7. And -3 goes to 4. What's up? And 8 goes to 7. Okay. And I'm going to go here, and I'm going to make this one be same size. Good? Okay. So the question of the day is, if you could get any pet, tap the brakes, I'm still on this. Here. Question of the day. If you could get any pet, what pet would you get? If you could get any pet in the world, okay, real or fake, I'd be okay with that. Okay, my answer, I'd probably get a orca, because I think they're just beautiful. Okay, so I'd get an orca and I'd put it in my back pond. Okay. Let's talk functions now. A function is a special relation for which each input has exactly one output. Okay? Each element of the domain is assigned exactly one element of the range. Another way of saying it is there are no repeats in the domain. Okay. So there's no repeated numbers in the domain. Okay. So let's look at these two different relations and decide if they are functions. Okay. So what we need to do then to decide if a relation written in point form, this is a relation written out in point form, is a function or not. Well, what we have to do is we have to look at the x values of each of the points. If all of those x values are different, it's a function. If there's a repeated number in there, then it's not a function. Okay. 3, -1, 2, and 4, all of those are distinct and different. So yes, this one is a function. Thumbs up or thumbs down if you think B is a function. Thumbs up if it is a function. Thumbs down if it is not a function. I see lots of thumbs down, and it is not a function because we have a repeated value here at -1. So this one is not a function. Conjunction junction, what is your function? Okay. Love it. Okay. Functions can be evaluated. Actually, what I should have done is I should have put, no, that's okay. Functions can be evaluated for any value of x. Okay? So remember, function notation looks like this. We've got a letter out in front, and then we've got a defined variable. So in this case, our function's name is f, and the variable in that function is x. So we call that f of x. Okay? So our function has been defined as f of x equals 3x minus 4. We want to evaluate that at, or we want to find, if you will, f of -2. Well, so if I find f of -2, if you'll notice, what I've done here is I've replaced x with -2 on the left. So on the right, I would do exactly the same. I would replace x with -2 in any and all spots. Okay? 3 times -2 is -6. -6 minus 4 is -10. So f of -2 is -10. If I input -2 into my function, the output that I get is -10. So -2 would be part of the domain, -10 would be part of the range. Okay? With that being said, what I would like you to do now is I would like you to do those two. Find me what h of 4 is and what j of 2 is. I'll give you a couple of minutes here to complete those two problems. what's going on. I should read what people want to get for pets. Gabe, what's a Tibetan Mastiff? I'm gonna have to Google that one. Oh, okay. What is it? Is it a big? Okay. Oh, gotcha. Nice. I don't know if I've ever seen one of those. I'm gonna have to look it up. Couple of pandas, couple of bears. Love it. Couple people would fit well in the Linsmeyer household with dinosaurs and dragons. Love it. All right, so on h, so on h of x equals 2x plus 6, you should have gotten h of 4 is 14. Yes? Thumbs up? Love it. Thumbs up on that one. Okay? 2 times 4 is 8 plus 6 is 14. On j of 2, you should have gotten 19. Okay? 2 squared is 4 times 3 is 12. So you have 12 here, plus 2 times 6 is 12 more, minus 5. So that's 24 minus 5 gets me 19. Yes? Good. Thumbs up, thumbs down. Love it. Awesome sauce. Okay? How can we tell if a graph, so when we're dealing with a function and we have either, if I would go back to the original 4, here is the original 4. If we go back to this, in an ordered pair, we look for repeated x values. In a table, we look for repeated x values. In a mapping, we look for 2 arrows coming out of the same one. Okay? On a graph, though, how do we tell if a function is, or if a relation is a function? Well, that's actually relatively easy. So if I have like this, or if I have something funky like this, my Algebra 2 teacher would be mad if I didn't put arrows on the end. Or if I have something like this. Okay? All of those are relations. Okay? All right? How do we tell? It's actually relatively simple, and every single one of you has the tools. You have multiple tools within your arm's reach right now to do that. Okay? How we do that is we do something called the vertical line test. Okay? Now, do you have to have something that is truly vertical? No. You could have a pen. You could have a pencil. The edge of a piece of paper is a vertical line, could be a vertical line. Your phone has straight edges on the sides. Anything that's straight that's within arm's reach can be. Your finger can be. You can take your hand and slide it across the graph. And what you're looking for is you're looking for if that relation, that graph, ever touches this vertical line in more than one spot. So this first one is a function because it's only ever touching in one spot. This second one is a function because it's only ever touching in one spot. This third one is not a function because right there it's touching in 4 spots. Okay? So function, function, not a function on those. Okay? The vertical line test says that if you take something and you vertically scroll it all the way across your graph, as long as it only ever touches in one spot, it's good. If it touches twice, badness. Okay? Let's talk some kinds of easier functions. Okay? The easy functions are linear functions. Linear functions are a special relation. Does it fly away? Nope, I thought it was going to fly away if I touched it. Okay? It's a special relation that graphs into a line. Okay? So it's going to graph into a line, okay? Which you've done many times before. And you've graphed many lines before. So you normally have them as y equals mx plus b, where m is the slope and b is your y-intercept. Well, now in function notation, we change the y into f of x. Okay? If we write it as y equals mx plus b, that's just kind of regular old notation. If I write it as f of x equals mx plus b, now I've written it in function notation. Okay? And remember, this is not the cable channel fx, it's read f of x. Okay? All right? There are multiple ways to actually graph linear functions. Okay? One way, one method is you could make a t-chart. Okay? Where you pick 3 or 4 x values, plug those into your function, and get out the corresponding y values. Okay? You've done that many, many times. Okay? Next way is the y equals mx plus b method, where m is the slope of your line, rise over run. And b is the point 0, comma b. It's the y-intercept where it crosses the y-axis. Okay? So you would plot your y-intercept, and then you would use your slope, rising and running, to get the next point, and so on and so forth, and then you want to draw it in. Okay? The third method, you could always use a graphing utility. So if you had a graphing calculator, or if you use Desmos on the website Desmos, those are all fine and dandy. The only downfall with those aren't on a piece of paper that you can then turn in. Okay, so that's graphing calculators or graphing utilities, I'm totally fine with. Okay, but you got to transfer it over. And the third way is called the intercepts method. So the y-intercept is where x equals 0. So you would plug in 0 for x, and you would get out a value. Okay. The x-intercept is where y is equal to 0, or in this case, where, oops, that's a bad or where f of x is equal to 0. Okay. And so you would plug that in, and then you would solve for x, and that would give you 2 points to graph your line. Okay. Now, in terms of homework, if you have graph paper, great. If you have access to a printer, I will have graphing paper available for you to print out on its learning. If you don't freak out. Okay? Just draw a grid on your paper as best you can and represent the line that way. But if I'm asking you to graph a function, I expect to see a to-scale graph somehow, either on an actual piece of graph or on a well drawn out graphing thing or graph that you created on your piece of paper. Okay? So let's try one of these because we've done a ton of graphing before in our lives, just to get back to thinking about it. Okay? So if I wanted to do it, and I will actually represent this in all 3 methods. Okay? So my first method would be I need to pick some x values. So I'm going to pick a negative number like -3. I probably want to pick 0. And I want to pick a positive number like +4. Okay? So I'm going to pick those numbers. Now I'm going to plug those numbers individually in. -3 times -3 is +9. +9 plus 2 is 11. So the point 3, -11, or excuse me, -3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 is on my graph. Plugging in 0. -3 times 0 is 0, plus 2 is 2. So the point 0, 2 is on my graph. 4. -3 times 4 is -12, plus 2 is -10. So I would go 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So I get those. Okay. Y equals mx plus b method. Well, I first go up 2 from the origin. That's this middle blue dot right there. And then from there, I would go down 3. 1, 2, 3, right 1. 1, 2, 3, right 1. 1, 2, 3, right 1. 1, 2, 3, right 1, and I'm at that other blue dot. If I don't like going down and to the right, I could always go up and to the left because it's negative, and then we get there also. Okay. Intercept method, probably not the best in this case. If I plug in 0 here for y equals -3 times 0 plus 2, that's going to give me y equals 2. So that's going to be the point 0, 2. That's this one right there. Okay. 0 equals -3x plus 2. Now I've plugged in 0 for y. That's going to be -2 equals -3x. That's going to be x equals 2/3. So this would be the point 2/3, 0, which is kind of hard to graph. Not going to lie to you because it's a fraction. It's not a nice whole number, but it would be right in about there. Okay. When it's all said and done, I would prefer that you use something straight to draw your lines. License, ID, edge of a book, edge of a piece of paper, ruler, something straight to draw in these lines then at the end. So I got to get my right color, and I want to get my right width, and then I would go right like that, and there's my line. Okay. Handle. Okay. Now, the nice thing that I have for you is that I'm giving you tomorrow off. Okay? I got nothing for you to do tomorrow. I've got no formative assessment for you to take. You guys are off until Monday for me. Okay? Make sure that if you're one of the 13 that still has to take your test, that you get that done today, because after that, you'll have some form of a penalty for being late. Make sure that you get your week 3 homework done. That was the review assignment that you should have had done prior to taking the test. Make sure you got that done. And then make sure you got everything else all at 100% on all of your other ones. Okay? I'll be around for the next 10 minutes here in this chat if you wanted to stick and hang and ask a couple of questions. If not, honestly, have yourselves a great, wonderful weekend. I think it's supposed to be relatively nice this weekend, so get outside and enjoy it. Okay? All right? See you on Monday.